Welcome to the next module. In this module, we will be studying about permafrost and biogeochemistry relationship. So what is permafrost? Permafrost is basically the ground that remains frozen for at least 2 consecutive years consisting of soil, rock or sediment. So this is the basic definition of permafrost. Permafrost, permanently frost. Then what is the extent? This actually covers 24% of the exposed land area in the northern hemisphere, containing approximately 1400 gigatons of organic carbon. So this is the biggest source of carbon. This is the source. And what is the composition? It contains organic carbon, ice and mineral soil layers with up to 88% of its carbon stored in frozen organic matter. So this is when we studied about carbon cycle, we also saw about the permafrost, where lots of carbon is being stored in the permafrost. Why we are worried about or concerned about permafrost? This is susceptible to thawing. When the temperature increases, because this is what we are seeing, Arctic amplification leads to increase in the temperature. The increase in the temperature actually heats up the land also. So the ice which is present below soil also starts melting. So this is susceptible to, that process is called thawing. Due to the climate change, with projections and estimation of loss of around 90% of near surface permafrost by 2100 under high emission scenarios. So there are various scientists who are actually working on this particular area. And in fact, the IPCC's Polar Regions 2019 report talks a lot about this permafrost. This article you can read to get more information. So here is the actual picture where we talked about the northern region has lots of permafrost. So basically the dark color, that purple color is basically here you can see the glaciers are present here. So below this we have lots of permafrost. This image is a circum-Arctic map of permafrost and ground ice conditions. So here the amount or the extent is actually given in different colors. So we can see this dark purple color is basically glaciers, and other areas like the slightly grayish areas, they have around 90 to 100% of permafrost. So if you look at the border areas of Greenland and also the major portion of Russia, and especially the northern part of Canada, all these, and even in Alaska northern part, all these areas have this grayish region, and this grayish region means it is 90 to 100% permafrost region. And other areas are discontinuous permafrost is given here. And then we also have a very isolated permafrost that is also given here in these regions. So here again, if you see the Himalayan region, there also we have some of the areas where we have the permafrost. So if you look at completely, the northern region has lots of permafrost. So what are the problems or the challenges that are facing permafrost? One is the temperature increase. So the global warming trends basically, according to the IPCC report, the global temperature are rising by approximately 1.2 degrees centigrade since the pre-industrial times, with Arctic temperatures increasing at more than twice the global average. So temperatures are increasing globally. What will happen to the permafrost? The permafrost temperature, because various studies show that the temperature of the permafrost has also risen significantly. When the temperature rises, what it leads to? It will leads to thawing. So for instance, the data from the Arctic coastal plain of Alaska indicate that the mean average ground temperature has increased by approximately 3 degrees centigrade over the last few decades. So this tells that when the global warming happens, the permafrost also is being affected. So how much is the extent of this thawing? Basically, paper published in Nature Climate Change talks about 24% of the northern hemisphere's land area is underlying by the permafrost. It is estimated that the area near the near surface permafrost is basically shrinking. That means the soil is getting warmed. So that means the ice is completely gone now. So that becomes like a normal soil. A study found that by 2100, around 30% of the permafrost could be lost if current warming trends actually continue. And the thaw depth is also another thing, it had actually increased significantly. What does it mean? So what is the change in the thaw depth? That means the depth up to which the ice melts actually keeps on increasing within the permafrost. So a study from 2020 found that the average active layer, what is active layer? The layer of the soil that thaws in the summer, that is what is called active layer, because below that is actually frozen at least for 2 consecutive years, then only it is called as a permafrost. So the active layer which is at the top basically starts melting or thawing. This had increased by 10 to 30 centimeters in some regions in the past 50 years. So this is one of the reasons the climate change leads to increase in the thawing of permafrost. Then the next one is the greenhouse gas emissions. The research estimates that permafrost contains about 1500 billion metric tons of carbon. A 2000 study in Nature suggested that if the permafrost starts thawing, then it will actually release all the stored carbon. Up to like 1.3 billion metric tons of carbon can be released annually by 2050. This will actually lead to lots of global greenhouse gas emission or increase in the global greenhouse gas. And of course, methane emission is also another biggest problem. So, methane, which is a potent greenhouse gas, also is released during permafrost thaw. So, 2021 study in Nature Geoscience showed that the increased microbial activity in the thawing permafrost could lead to methane emission that will exceed whatever was the previous estimates. See, the methane is stored in the permafrost, but it is not simply released. The microbial activity also converts whatever the carbon, the soil carbon is also getting converted to methane. So that means it is like a double whammy. So 2 types of problems are actually happening simultaneously. One is release of gases. The second one, conversion of carbon into these dangerous gases. Let us look at the impact on infrastructure. See, when the soil thaws, basically the permafrost thaws, what happens is the soil becomes very loose. The ice which was present is completely melting. So that will make the soil like a soggy one. So if some building is constructed on this one, that starts collapsing. So according to the report by the US Army Corps engineers, the infrastructure damage mainly related to permafrost thawing in the Alaska is estimated to cost billions of dollars, with potential loss up to 5 billion in the next few decades if the current permafrost thawing continues. And what is the feedback mechanism? A study published in Nature in 2019 highlights that the feedback mechanism is associated with permafrost degradation. That is, thawing actually accelerates the climate change by releasing greenhouse gases, which in turn leads to more warming and further thawing. So this feedback loop, which is called a positive feedback loop, actually leads to more permafrost thawing.